Hello and welcome to the Scientific Adventures of Beardman. Today we're going to be looking at a concept builder on physicsclassroom.com in the topic Relationships and Graphs, titled Which One Doesn't Belong? Throughout the course of the year, there's several with that title, so I identified this as the graphing one of those. In the calculating slope video, a couple of videos ago, a couple concept builders ago, I went through this slide. I'll link the video here if you want some more detail on these relationships. So in this concept builder, you're going to have 3 or 4 different ways of identifying a linear relationship, inverse relationship, and quadratic relationship. And you'll notice that 2 of them are linear and 1's quadratic, so you'll pick the quadratic. Or 2 are quadratic and 1's inverse, and so you'll pick the inverse, the one that doesn't belong. So let's go through the first ones I'm calling relationships. They'll read this way. As the value of x is doubled, the value of y is doubled. Well, if one thing is changing the same way as the other one is, that is a linear relationship. All right. And I should mention that in the proportional relationships video, I went through and detailed a lot of what these are. So I'll link that here. And if you need feedback or if you need more explanation of what these are, that's a good place to go. Second possible example that you could have is as the value of x is doubled, the value of y is halved. Well, if one thing's getting bigger by a factor of 2 and the other one's getting smaller by a factor of 2, that is an inverse relationship. Keep in mind, by the way, this could be tripled and tripled or quadrupled and quadrupled as long as they're doing the same thing. This could be doubled and halved, multiplied by 2, divided by 2. It could be multiplied by 2 and divided by, or multiplied by 3 and divided by 3, tripled, and a value is 1/3 of the original value. That would also be inverse. Finally, as the value of x is doubled, the value of y is quadrupled. In other words, times 2 times the square of 2. Okay, so it's going to be the one is the square of the other. That is quadratic. When we have x squared terms, those are quadratic relationships. All right, so you'll see one of those in every single problem, and it's either going to be linear, inverse, or quadratic. Then you'll also see a graph on each problem. If the graph looks like this, that means if x is getting twice as big, y is getting twice as big. That would be a linear relationship. Hey, a linear looks like a line. Perfect. Next kind of graph. If we start at this point and we make x get twice as big, well, y just got cut in half. It was up here, it's down here now. So that's an inverse relationship. The shape of that graph is a hyperbola. And next we see this kind of graph. If y gets twice as big, if x gets twice as big, y is going to get 4 times as big. Okay, so y goes from there to there when x just doubles. Okay, that is a quadratic relationship. The shape of that graph is a parabola. Then you will also see, so you're going to match, if you see this and it says when one doubles, the other quadruples, you're like, those are the same. It's not going to be that one. Okay, so you're going to just pair them up. Then we're going to see data tables. First data table we'll look at over here. We see when this doubles, goes from 1 to 2, that's doubling. We see y doubles, goes from 2 to 6. We can check 2 to 4 also. 2 to 4 is doubling. 6 to 12 is doubling. That is a linear relationship. They're changing the same way by the same factor. All right, here we see as we go from 1 to 2, we double. This one gets cut in half. Similarly, if we multiply by 3, this is divided by 3. If we multiply by 4, it's divided by 4. Okay, that is an inverse relationship. As one is getting bigger, the other one is getting smaller. Finally, if you see one where the x doubles, going from 1 to 2 doubles, and 5 to 20 is 4 times bigger, okay, well that would be a 4 times bigger. That would be a quadratic. This is 2 times, that's 4 times. You could also go 3. This is 3 times bigger. 3 squared is 9. So 5 to 45 is 5 to 45 is 9 times bigger. So that is a quadratic relationship. So once again, in the master level, you'll have one of each of the 3 types of things we've already looked at. You'll find 2 of them are inverse and 1 is quadratic. You would select the quadratic. Or you'll find 2 are linear and 1 is inverse. And so you'll select the inverse. Or 2 are linear and 1 is quadratic. You'd pick the quadratic one. I should mention there are also some, I forgot to put examples of this in the screen, but on the graphs, you will see some where the data is not changing. If the line is going straight like that, that means whatever value this is, and I don't think there are numbers on it, the x value, no matter what the x value is, the y value is 4. That means there is no relationship. So that would look, in this case, like having our numbers here like this, and this number just doesn't change. Okay, so sometimes those 2 graphs will match up, and then the one that's different will be one of the ones either a linear, inverse, or quadratic. This would be no relationship whatsoever. All right, and finally, in the wizard level, you will come across equations. So if you, in math, you're probably used to y equals mx plus b. That's the equation for a line, which is a linear relationship. In physics, we tend to use k as a generic constant. So we'll assume it goes through the origin. So b is 0. And so instead of y equals mx, you'll see y equals kx. Okay, sometimes k will be a number because it's a constant. It could just say y equals 2x or y equals 3x, or it could say y equals kx. Next kind of relationship is an inverse. When x is getting bigger, y is getting smaller. Okay, notice we use k as our constant. So that would be an inverse relationship. However, this concept builder doesn't draw it this way, with the y in the numerator and the x on the other side of the denominator. Instead, it multiplies both sides by x, and this is what you'll see for an inverse relationship. Y times x equals k. I like this one better because it shows you when one's in the numerator, the other's in the denominator. Shows you, it's easier to see when that changes, how that changes, I think. But that is the same, and that's what you'll see here. Finally, if we see the x squared, we know that it's quadratic. Keep in mind the k in any of these could be a number, a constant, like 2, or it could be the letter k representing it could be any constant. So once again, in the math wizard level, you'll just have all 4 types of things. You'll have examples, you'll have graphs, you'll have tables, and you'll have equations, and you find the one that doesn't fit. Good luck puzzling that out, and if you have any questions, put them in the comments below. If you enjoyed this video, click the like and subscribe button, and we'll see you the next time on the scientific adventures of Beardman.